Are you ready to show what you've learned?
Yes, I'm ready. I'm ready to do this.
Okay, really? Sure? We're good?
Yeah, we're good.
Okay, here we go. Welcome back to the Tube Barn. This video is going to be a little longer because I've decided to group some things together. And what are we discussing? We will be discussing diodes, rectifiers, and transformers. That's right. We're going to be discussing diodes, rectifiers, and transformers. I've got my breadboard. We're actually going to build a couple rectifiers. But before that, let's discuss sine waves. Now, if you don't know what a sine wave is, it's pretty much AC. It's the signal. It's also your power source. I should say into your transformer. It comes from the house. That's AC. It's a sine wave. So, now a sine wave is you have this. Like that. It goes up. Now, when you have your transformer, you got your transformer, you got your mains coming in here, and you got all the windings, and you got your secondaries coming out. There's more secondaries depending on what it is. Now, AC cycles, which is how you get this. From the transformer, it's bouncing back and forth from here to here, should say here, in, out, well, it's out. It cycles, depending on where you are, 50 to 60 times a second, which is what they refer to as the 50, 60 hertz. Now, what you're doing in a rectifier is you're blocking it from going backwards, which is the negative voltage. We'll get to that in a little bit. So basically, all you want is just forward current to create DC, which is direct current, which you want it to see like this. Now, what happens, I'll move this paper up a little bit, is after you rectify it, and before you put any smoothing caps on it, you ended up with kind of this. Because what happens is as much as you're getting 1, 1, 1, 1, 1, it's pushing out. You're still going to have gaps because it's like this. That's what they call peak to peak, peak to peak. You get gaps because it can only do so much. Now we'll discuss what the smoothing caps do, but they fill in these gaps. We'll do that in another video. So if you're not understanding what I'm talking about in regards to these sine waves, go ahead and check the link in the description for Valve Wizard. He's got some really good information and explains this a hell of a lot better than I do. I'm more practical, and that's just me. And for anybody that wants to jump ahead and not listen to my bullshit, you go ahead and check the description, and I'm going to have the times for the different items that I am discussing in this video. But let's get started. First thing we're going to discuss is a full wave bridge rectifier. Get your handy dandy diodes out, which are here. And what you're seeing is these stop current. These only want current to go one way. And how do we know which way that these go?
It's the white line. It's the line that says the direction of the current.
That's right. So how do we build this thing?
Well, you need to make two pairs of diodes in series. Connect the anodes of the first one and the cathodes of the second one.
Okay, cool. And so you know, anodes, cathodes, it kind of is confusing when it comes to direction of power from what we know. Look it up. It's a long story about Benjamin Franklin and some cheesecloth screwing up how things are actually done. It's kind of a funny story. Okay, so as you said, we're going to put two pairs of diodes in series. Where do these secondaries connect?
The secondaries connect in the middle.
So we need to make sure that these centers don't touch.
Yes, that is correct.
Put that right there then. Breadboards don't like to be friendly, and these diodes are very soft. Okay, let me get another one. Okay, so connect it here, and then connect it here. Now connect this one here. Get in there. And that one goes there as well. Let's check our work. That looks correct. Nothing's touching. Let's get some handy dandy meter out here and check some connectivity, make sure we're not touching anything. Okay. That's not touching. That's not touching. These are touching. These are touching. That's not going backwards. We're good. Okay. So what do we do now?
We have to connect the secondaries.
Okay. Let's use these alligator clips here. Let's do that. Boom. You can see I've had my transformer connected to the power. This is the ground and the screen. I'm sorry, the ground and the screen goes here, and this is one end of the secondary, and this is the other end. Connect one here, and put that down. Try not to touch anything. Now we're going to put the other one here. Okay. Ooh. So what's next?
We need to ground the anode.
Okay. Let's ground the anode. It's here. Try not to touch anything. Okay. Hopefully we have enough connection. This is definitely not going to be good to actually be useful just for testing purposes. So, let's power this baby up. Boom, we have power. Let's get into our AC mode and just see what we're dealing with. When you're using your meter and probing, it's best not to use two hands. Get that in there. No, but for this circum, I am going to, because I don't have any way to connect it. So, first let's just check the AC. We got 411 there, 210 there, 180. Fuck. 0. So we have 3 or 10. We have 230. 230. 278. 412. 412. What the fuck is wrong with this thing? So I had to go and check this circuit out. There was nothing wrong with it except the fact that this diode is shorted. Brand new, completely shorted both ways. So it was giving me all kinds of craziness. See, it should only have voltage go one way, and it should have a lot of resistance to it. Well, not a lot, but you know, it's not going to just ring true. See, it's ringing. Reverse voltage. No, is that reverse? I can't tell which way is reverse. I can't see it. But anyways, it's not supposed to ring both ways. So it was completely shorted out, and that's why I was getting crazy information. Now, one thing you know too, these transformers tend to get a little nuts when they're not under load, so their voltages are higher than they actually will once you get it going. Now with this one, it works. Oh, that's not even on. Yeah, so can you even see this? No. Anyways, I can't put it in there. So yeah, we're good. We're getting what we should be on both ends. Fairly even. Well, the voltage is significantly higher than it will be under load. So that's just the way of transformers, especially these toroidals. They get crazy. So, turn it off, or shock myself. So as you can see, here's my probe. Rectifier diode bridge, you have two in series, another two in series parallel to those. The anodes are connected, the cathodes are connected. The voltage comes in here from these secondaries. The voltage goes this way, this one goes this way, connects here. So what happens is you get this side, so you're going boom, 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 which is giving you your DC without the caps. It's a little ripply. So let's talk about the back side of it. This allows negative voltage to move this way, but not positive voltage. Now, if you ground this, it acts as a center tap. If you don't have a center tap on your secondaries from your transformer, this works to compensate for that, if this is what you're using. Now, also, if you wanted to have a circuit with a positive and a negative voltage, you would use it like that. And that's pretty cool. I'm not going to be doing that because that's not part of what I'm building. Now, if you do have a center tap, I'm going to move this out of the way. If you do have, and this is the transformer. Now, I use S29 toroidal transformers.
That's right, S29 transformers. These clean powerhouses are just what you're looking for. Specially designed for your 2 power amp needs. Not 1, but 2 power amp models to choose from. Center tap secondaries, bias tap. You need 12.6 on those preamp heaters? We got you covered. Double tap. Check out this preamp model. What's that other secondary for?
Phantom power!
Buy 2 at regular price. Thank you. S29 transformers. You'll love them so much you'll want to put your dick in it. That's why there's a hole.
Now, looking at the transformer windings, I don't have much room on my camera, so we'll talk about the mains. Like I said earlier, these are your mains. It's got a screen that gets grounded. And here, this one is rated for 320, what they refer to as 320 peak to peak. Vroom, vroom. So it goes here, 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 here. It's cycling all the way back. All crazy. Here are your zero windings. This one has a center tap. The reason why it has this separated like this is to be Roche compliant. They had to do it as double. So you will connect these two and ground them if you are grounding a center tap. If not, then you would use them. You just connect them and cap them and do nothing with it. Here is your bias tap for your negative voltage for your power amp section. Now, you come down here. Now this one, I had it built a little differently. If you know about standard AC, you have old school 110, 110, put them together, it's 220. They pretty much meet in the middle, boom, 220. And that's what happens here. Now you have your 6.5 and your 6.3 and your 6.3, which gives you your 12.6. Now I had these put on here because I want to use a higher voltage, which is less amperage, less current. The theory is it's less possible noise crossing over into your tubes. I used both, haven't really had an issue, but I put them on here anyways. Then of course, you have your standard 3.15 for your 6.3, which power tubes. This is what power tubes run at, so you have to have that for your power tubes. The preamp tubes, you can get different variants of what that is, but I'm going to use the 12.6. Of course, I have a center tap here. We'll discuss heaters later. If you don't have a center tap, you use a couple 100 ohm resistors and you create one. I'll show you how to do that later. But that's that. Now, let's go to a different rectifier. Okay. It's goddamn cold out here. Okay, we're going to talk about another rectifier, one that I'm going to be using in the amp that I'm going to build in this series. Now, it's a simple difference. You literally go like this. So what's the name of this rectifier? This is also a full wave rectifier. No, that's similar, but that's not the same. I should know this. You've told me. I get stupid. Jesus Christ, Dobby, calm down. We're just learning. It's all good. I told you that goddamn kid was too stupid. God, good for nothing piece of. What the hell did I say about coming to my barn? I swear to God, I'll burn your goddamn eyes out. You get the hell out and don't come back. Stupid ass bullshit. I don't need this right now. Oh my God, oh, not you. I don't have time for you right now. Oh no, go ahead and leave that. Just get the hell out too. Now, I don't recommend drinking beer during your builds, but it's not very safe. But you know, there's a reason why I can do this. It's because you're an alcoholic? No, it's not because I'm a goddamn alcoholic. It's because I'm a professional. Shut up. Let's just build the goddamn thing. Let's get back to what we're doing. Anyways, where were we? We were discussing this one. Yes. Okay. This looks very similar. But if you look, these anodes are no longer connected. What's going to happen is when you bring in your voltage, your secondaries, you're going to be here on the ends. This one is called a two-phase rectifier. It uses both halves of the sine wave, but we're not connecting the anode to ground. And the reason why we're doing that, we're going to be using the center tap, so therefore these cannot be grounded. Now, if you ground a center tap and you ground your anodes on a full wave rectifier, it will create a big short, and it may not black out or blow fuses, but your whole chassis will shake. This transformer will shake like crazy. Not sound coming out of the speaker, I mean the whole thing will. I learned that the hard way a while back. Now you can use just 2 diodes. You don't need to have these series. But the reason why I'm doing this is because of my transformer voltage rating. I have my peak to peak at 320. Now, to calculate your diode, these are rated for 1,000 volt. Those are the pretty standard ones that you're going to have in your rectifier available. Higher than that, it starts getting expensive and a real pain in the butt, so stay with this. Now what you do is you take your diode rating, which is at 1,000 volts. You divide that by 2.8. Then you're going to want to take off another 19% just for safety, because voltage is always changing. One place is 110, one's a 124, and we're talking about your supply voltage in your house where you're plugging your amp in. Then you have different regulating issues and stuff. It's just a safety thing. So you come out with about 290 volts peak to peak that you should be working with these diodes. Now, like I said, mine are at 320 volts peak to peak, so it's above this. So what you do is you put another one in series. That'll help share the load. Now, what we're going to do, let me get these out of the way. But what you want to do to help balance it relatively is you're going to take these capacitors. They're ceramic capacitors, and that don't want to come off the tape for anything. Jesus. Seriously, who taped these? I mean, people are going to use these. So you're going to take these capacitors and you're going to run them in parallel with your diodes. One there. A lot easier when you're soldering this together. and you're running them like that. And you do it on both sides. This helps the diodes evenly share the load. Now, once again, this area is where your voltage comes out into your system to your smoothing caps and the rest of your power supply. So there is no grounding of this at all. Those are the two types of rectifiers you're going to be using for your power source. If you have a center tap on your secondaries and you're going to use it, then you want to use the two-phase. If you don't have a center tap, you're going to want to use the full wave bridge rectifier. Now, let's get to the last one. This is the one that you're going to use for your bias supply, your negative voltage in your power amp section. What's this one called? This one is a half wave. That is right. This is a half wave. And the reason why it's a half wave, because you're only using half the wave. And normally you're only going to use these in your bias supplies. If you use them in any other type, you're going to have some really, really huge capacitors, because the smoothing, you're literally smoothing half of the wave. And like I said, I'll explain that in the next video when we talk about capacitors. Now, because it's a negative supply, you're going to have it backwards. Well, depending on orientation. You put it in there. Good enough. And your power will come in this way. Do you remember how this one works?
Yes, the power doesn't go in this direction. It does not allow reverse current.
That is correct. It does not let positive voltage move this way, but it will let negative voltage move that way. I guess for me, I would call it kind of like vacuum. It's negative, it's pulling. Negative voltage is strange. Bias rectifiers are pretty simple. A diode, a resistor or two, depending on what's supplying it. And of course, a capacitor. Only requires one. I usually use about 100 UF capacitors. And like the diode, they're flipped upside down. It's fairly simple. Of course, there is a pot to trim it up and down. Like I said, we'll get into those details as we move along. Let's talk about transformers for a second. These are the type I use for the power stages, which is the toroidal. I can't quite say that word. Maybe I'm saying it right. I hope so. This one is for preamps, lower voltage, lower amperage. Now, I like these. They're very clean. I find them to be cleaner than the traditional ones, but of course, newer technology, older stuff, maybe there's no difference. But one main issue I have with these is their size. You can see that. This thing's big. If you're using the little chassis pans, you may have an issue with getting it to fit on it. Now going back to this. And unfortunately, you can't really put it on your end like this because the magnetic field shoots out, what's that, like a pulsar, like this. Now, normally, it's mounted over your power supply, which isn't really causing much. It does have this pan. It does protect a little bit to some extent. They do make some big cast iron covers for these things. They're extremely heavy. And the reason why you don't want this, because then it starts pointing at your output transformer. It could affect noise on that. If you have it this way, it starts affecting your power tubes. Plus, it's kind of hard to mount like this. So there's always good and bad in all things. But that's what I like with them. That's all there is for this video. I hope I've helped you. I hope to have another one out soon. It's winter, it's cold. It's a little harder to film out here in the barn. Anything else you got?
No, I'm good. Thank you.
Okay, so see you next time.